Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-8 Part 2 homework solutions on polynomial and rational inequalities. To solve this inequality, we first need to find the critical values and put them on a number line. To get the critical values, I'm looking for places that are going to either zero out or make undefined this rational expression. So to see what zeroes out the denominator, that's going to be our undefined discontinuities. Let me first factor that. It looks like I can take out a 3 down there, and that'll leave me with an n squared minus 4. And then I can factor this a little bit further into n plus 2 and n minus 2. So we have a 3 still there, an n plus 2 and an n minus 2. All right, let me list my discontinuities first, just so I don't confuse them with roots. So for this positive 2 down here, we have a negative 2 for that root. And then this n minus 2 gives us a root of positive 2. Now looking at my numerator, the only thing that's going to zero this out is if I plug 4 in for n. So that's going to be my single root. Putting all this on a number line now, the roots are going to be solid dots because I have an equals on my inequality, and the discontinuities are always open dots. So the furthest one to the left, this negative 2, discontinuity, open dot. And then 2 is the next one in line, also an open dot. And then this root of 4 gives us a solid dot over there. Let me go ahead now and try out some numbers in each interval to see where things are positive and negative. So to the left of negative 2, I can use negative 3. And as I do a little analysis here, I'm just taking a look at this most factored version of my rational function. My numerator has a squared term up here, or a squared factor, I should say. So that means that I'm always going to get a positive numerator no matter what. So I don't even need to look at this stuff up here in order to do my sign analysis. I'm just looking at the n plus 2 and the n minus 2. So plugging negative 3 into both of those, negative 3 plus 2 is negative, negative 3 minus 2, also negative. 2 negatives gives me a positive. Now between negative 2 and 2, I can use 0. 0 plus 2 is positive, 0 minus 2 is negative. 1 negative gives us a negative result by multiplying. Between 2 and 4, I can use 3. 3 minus 2 is positive, so is 3 minus 2. 3 plus 2, 3 minus 2, both positive. So that's all positive. And something bigger than 4, like 5. 5 plus 2, 5 minus 2, all coming out positive. Looking at my inequality, we have less than 0. That means I'm looking for negative intervals after I've labeled things. The only negative interval is this one between negative 2 and 2. So when I write my solution, I'm going to write negative 2 comma 2, and I'm going to use parentheses because I have open dots on either end of that. Oh, wait, there is one more before I forget. We have a solid dot over here at 4. Can't forget about that. So I'm going to union squiggly braces 4, and this is everything that I need that satisfies this inequality. To solve this inequality, we're going to start by getting some critical values out of this. Those are anything that are going to make either the numerator or denominator 0, basically the roots and the discontinuities. So let's do the discontinuities first. In the denominator, I can zero that out by making x 4. So we have a discontinuity at 4. And then for the roots, in the numerator, we have a negative 2. That'll zero out that first factor, and also positive 5. Now that I've got these, let me put these on a number line with the correct types of dots. So the furthest to the left is going to be this negative 2. And since that's a root or a 0, and we have an equals in the inequality, that means that this is going to be a solid dot at negative 2. Next up, we've got this 4, but since this is a discontinuity, it's automatically going to be an open dot because we can't have any kind of solution there. And then this 5 is also a root, so that's going to be a solid dot at 5. Let me test something in each interval now and see what's positive and negative. So over here on the left, to the left of negative 2, we can use negative 3. And when I'm testing these out, this squared parentheses here, this is always going to come out positive no matter what I plug into it. So I can just ignore this and just focus on the x plus 2 and the x minus 4. So using negative 3, negative 3 plus 2 is negative. Negative 3 minus 4 is negative. 2 negatives gives me a positive. Next up, between negative 2 and 4, I can use 0. 0 plus 2 is positive. 0 minus 4 is negative. 1 negative gives me a negative. Between 4 and 5, a little bit tricky. I'm going to use 4.5 for that. 4.5 plus 2 is positive. 4.5 minus 4, also positive. Two positives gives me a positive. And to the right of 5, let me use 6. 6 plus 2, 6 minus 4, those are both coming out positive, so the whole thing then will be positive. So I have less than 0 for my inequality. That means I want negative intervals. So we have this interval right here between negative 2 and 4 that I'm going to shade in. And then to write that solution as interval notation, I'm going to be doing negative 2 comma 4. I needed a bracket on negative 2 because we have a solid dot there, and a parentheses on 4 because that's an open dot. So bracket negative 2 comma 4. And we can't forget, though, we also have this 5 out here that's a solid dot. So I'm going to have to do union and put a little squiggly 5 there to represent that part of our solution as well. On this problem, I'm trying to graph and write the solution for this inequality. Since we have a rational function, I'm going to start by getting critical values, which include roots and discontinuities, and then I'll put all that on a number line and do some sign analysis. So this is all already factored, so I can actually just go straight through and pick out my roots and discontinuities right off the bat without any other work. Let me start with the discontinuities. These will be things that zero out my denominator factors here, give us undefined basically. So starting here on the left, we've got a 5 minus 5 would give me 0. So 5 is one of my discontinuities. And for this next parentheses, 6, positive 6, will also zero out my denominator. Moving upstairs to the numerator, things that'll zero out the numerator now, we've got 3, that'll be one of my roots, and also positive 4 for this other parentheses. Okay, let's go and put those on a number line. Now, as I'm doing this, let me go from left to right here. The furthest to the left is this 3, which is a root. Now, since this is less than with no equals, since there's no equals in the inequality, the roots are going to have open dots. They're not going to actually be part of the solution. They're just boundary markers. So I'm going to have a 3 with an open dot. Next to the right here is going to be 4, also with an open dot. And now my discontinuities 5 and 6 automatically have open dots. So we have a 5 and a 6 there. Let me test out something in each interval now to see what we come up with. So to the left of 3, I'm going to go real easy here and use 0. And when I'm plugging things in, I can actually ignore this squared term because anything I square in here is going to automatically come out positive. So I'm just really looking at the x minus 3, the x minus 4, and the x minus 5. So plugging 0 into just those three to analyze them, 0 minus 3, 0 minus 4, and 0 minus 5, they all come out negative. 3 negatives, an odd number of negatives, gives me a negative overall. Next, between 3 and 4, I'm going to have to get a little bit clever here and use 3.5 or something in between those. So 3.5 minus 3 is positive. 3.5 minus 4 is negative. 3.5 minus 5 is also negative. 2 negatives gives me a positive overall. Now, between 4 and 5, I can use 4.5. 4.5 minus both 3 and 4 is going to give me both positives up there. The only negative I get is 4.5 minus 5. One negative gives me a negative overall. Between 5 and 6, let me use 5.5. 5.5 minus 3, 4, and 5, all of those are going to give me positive results. And again, we're not really caring about this squared thing because it's coming out positive anyway. So that's positive overall. And then if I plug in something to the right of 6, like 7, 7 minus 3, 4, and 5, those are all going to be positive as well. So I again get a positive overall result. Going through now, I need to pick out the intervals where we have less than 0, so those are going to be the negative intervals. That's going to be this far left interval and this dead center middle interval right here. Writing those out now in interval form, on the far left, I can write this as negative infinity, comma 3, and I'm going to use parentheses because we have infinities and open dots. And then I'll need a little union, and I need the interval from 4 to 5, also with parentheses. To solve this inequality, I'm going to have to get critical values. Those are going to be things that are roots that zero out the numerator and things that zero out the denominator, undefined values or discontinuities. In order to figure out what zeroes out the denominator, I need to first factor this. So my numerator, I don't really need to do anything special in terms of rearranging it. We'll take a look at that in a moment. In the denominator, though, I need two numbers that multiply to negative 28 and add up to negative 3. So we've got 1 and 28, 2 and 14, let's see, 4 and 7 is going to work. Positive 4, negative 7. So I can write that as x plus 4, x minus 7. And now let me go through and pick out, let me do my discontinuities first. I always do those first, just in case any of the numerator factors are the same. So for the x plus 4, negative 4 is going to be a discontinuity. That'll give us 0 right there. And for this next factor of x minus 7, positive 7 will be our discontinuity for that one. Taking a look in our numerator, things that zero out 2x minus 5. If I add 5 and divide by 2, I can write 5 halves, or 2.5, either of those, as my root. And that's the only root up there, even though it's a triple root. All right, let's put these on a number line and do some sign analysis. So my far left value is going to be this negative 4. Since that's a discontinuity, that's going to be an open dot automatically, without question. As we move to the right now, the next thing is actually going to be this 5 halves, which is 2.5 in disguise. Since this is a root, and since my inequality had an equals in it, that means the roots are going to count as part of the solution. So that means that we're going to put a solid dot on 5 halves, or 2.5. And then finally, the 7 is the last one. Discontinuity, again, automatically gets an open dot. All right, let's do some sign analysis. Picking a number to the left of negative 4, like negative 5. Now, the only kind of really tricky thing here is this cubed factor. When I raise something to an odd power, it preserves the sign of whatever I plugged in there. So I really just need to, look at one of these 2x minus 5s that are up here. I don't really need to think about all three, because one of them, the sign of one of them is going to represent the sign of having 3 of these. It's going to be exactly the same. So plugging in negative 5. Let's see here, 2 times negative 5 minus 5. That's going to come out negative. Down here, negative 5 plus 4 is a negative. Minus 5 minus 7 is also a negative. So I have 3 or 5 negatives, depending on how you think about it. Odd number of negatives gives me a negative result overall. Between negative 4 and 5 halves, I'm going to use 0 just to make my life easier. 2 times 0 minus 5, that's just negative 5, which is negative. 0 plus 4 is positive, 0 minus 7 is negative. So I have an even number of negatives, either 2 or 4, depending on how we think about it. That's going to come out positive. Now, we have to be a little careful here between 5 halves and 7. Again, 5 halves is about 2.5, so let me use 4 is between 2.5 and 7. I also could have used 3, but that's cutting it kind of close. So plugging 4 in, 2 times 4 minus 5, that's 8 minus 5, that's a positive. 4 plus 4 is positive. 4 minus 7 is negative. A single negative gives me a negative overall. And now something bigger than 7, like 8. 2 times 8 minus 5 is positive. 8 plus 4, 8 minus 7, all coming out positive, so we're overall positive on the far right. My inequality said greater than 0. So that means I want all the positive intervals. So there's this second interval right here, along with this far right fourth interval. And now writing all this in interval notation, for this first interval, I need negative 4 comma 5 halves. The negative 4 gets a parentheses because it has an open dot. The 5 halves gets a bracket because it has a closed dot. Now I need a union, and I'm going to do parentheses 7 comma infinity with another parentheses. For this rational function, to solve the inequality, let me start by getting my critical values. We'll start with the discontinuities, the things that make the denominator 0. Since this is already factored out, I can just go straight to figuring out what I need to zero out each factor. So x equals negative 2 would zero out this first factor of x plus 2 down here. And now for the second factor down here, negative 6 is the other one. Now for my roots, things that make just the numerator 0, we've got 5 and also 8 for each of those factors. Let me put these on a number line, and I'll do some sign analysis. So the far left number here is negative 6. Since that's a discontinuity, that's automatically an open dot. And then negative 2 is the next one in line, also going to be an open dot. For my roots, 5 is the next one. And since my inequality has no equals in it, I'm going to have to also use open dots for my roots. So open dot at 5 and open dot at 8. Choosing a number now from each interval to test it out here. To the left of negative 6, I can use negative 7. Plugging that in, we have a negative 7 minus 5 is negative. minus 8 is still negative, negative 7 plus 2, and also negative 7 plus 6. All of this is coming out negative. 4 negatives, even number of negatives, gives me a positive. Next, between negative 6 and negative 2, let me use negative 5. Negative 5 minus 5 is negative, minus 8 is negative, plus 2 is negative. The only one that comes out positive is negative 5 plus 6. So I have 3 negatives. Odd number of negatives gives me a negative. Between negative 2 and 5, I'm going to be going easy here and using 0. 0 minus 5 is negative, minus 8 is negative, plus 2 and plus 6 both come out positive. 2 negatives up here just gives me a positive overall. Between 5 and 8 now I can use 6. 6 minus 5 is positive, 6 minus 8 is negative. And then we have 2 positives down here. So just the single negative that I got from 6 minus 8, 1 negative gives me a negative overall. 1 bad apple spoils the bunch, I guess. And then after 8, we've got 9. So plugging 9 into all of these, we're going to come out positive for each of these factors. So that's a positive result overall. Now they said that we wanted greater than 0, so I'm looking for the positive intervals. That's going to be the far left, the middle, and the far right. And putting that in interval notation on the far left, I can use negative infinity, comma, negative 6. And I'm going to use parentheses on everything here because these are all open dots and I've got infinities besides. So negative 6 and infinity, negative infinity there. Union, negative 2, comma, 5. Union, 8, comma, positive infinity for that last interval.